Okay, we're going to try to recreate figure 6 using the tool. So figure 6 is what genes are differentially expressed based upon the expression of another gene. So we're going to look at expression stat. Okay, and I believe we used 9.5 as the cutoff. And the number of results back. That's a good question. Let's try 100. Okay, and so we're going to choose our gene, RB1, and our expression data set was breast. And we had some metadata for breast as well. Okay, so the idea here is that we're going to look at the expression of RB1, and we're going to group them into group 1, which are the samples which have less than 9.5 expression value for RB1, and then a group 2, which is greater than 9.5. And then we're going to do t-tests between these two groups for every other gene and return the top 100 results ranked by significance. So let's do that. And hopefully it will return. In the meantime, we should pick our meta value, which is going to be PAM50 there. And it probably has to load the data set. So the first time you run a query, it's going to load the data set into memory. And in subsequent queries, given that there's enough memory, it should be much faster because it should already be there. So, of course, RB1 should be the most significant gene, if that's what you're making the groups based off of. And so let's plot the heat map. Check that box. And let's do it again. So we want to look at what subtypes map to the groups based off of the RB1 differential expression. So what genes are most differentially expressed between group 1 versus group 2? And that's what gets returned here. And then makes the plot. Now this is a gigantic plot. And it's got over 1,000 samples. And Firefox actually loaded it amazingly. Okay. But I prefer to look at it in a real PDF viewer. Okay, so here, remember we looked at the PAM50 subtype here. So I'm going to make this smaller so it'll fit in the window. So we've got basal, HER2, luminal A, luminal B, and they're colored, and that's what this is over here. And you can see that where RB1 is high, which is, let's flip this, and so for RB1, actually it should be low. Okay, here, it's on the bottom. Where RB1 is low, okay, that's where a lot of these red ones are, and the red ones are basal, which is triple negative. And you can kind of see conversely that P16 or CDKN2A is high where RB1 is low. So it's interesting there. And so that's how you recreate figure 6. Now, in my tutorial on figure 5, I forgot to include the metadata, but it works the same way on every plot when you choose a metadata value on the heat maps anyway. you can choose which meta values to plot on the heat map. And so on figure 4, you would choose the CCLE plus annotation, and then choose the PAM50 value to get the annotations on the plot.